math. And on prior videos, I talked about something called the wave function, and I'm not really going to talk about that, but I think it's rather interesting, some of the math behind it. And in some of the chemistry videos, I talked about how we interpret certain calculations and certain solutions to the formulas that they use, the Schrodinger equation and whatnot. And I had mentioned some terminology, specifically something called the complex conjugate. And what we do is we don't know what the wave function physically means, if it physically means anything. But what we do is we find the complex conjugate of the wave function, and then we multiply the original solution by the complex conjugate, and we interpret that solution as a probability density, or probability for finding things, or probability for a certain thing to happen. And I just wanted to spend a little bit of time talking about this whole notion of a complex conjugate. And I'm actually going to talk about the complex conjugate in this specific video, because I think I need to provide just a little more background information. And where I want to start actually is on something called a complex number, or an imaginary number. And I'm not really going to talk about its applications today. I just want to talk about what it is, because it's kind of if you've never been introduced to this, and I think generally in school, if you take algebra, probably not like a first semester algebra course, but maybe if you take a few semesters of algebra, or maybe some pre-calculus mathematics, you've probably come across this. But at least in my mind, it's philosophically interesting, and it is just mathematically it's interesting. And what it is a notion of an imaginary number, or a complex number. And kind of the I don't want to say prototype, but kind of the flagship of complex numbers is something called I. So I'll go ahead and just throw that up here, I. And I has a rather interesting meaning. I equals the square root of -1. Now, I know that the intuition is probably to go, well, what's so special about -1? Obviously, it's a number. Why are we calling it imaginary or complex? Well, what I would do is to showcase just how interesting this argument, or just how interesting this concept is I would take -1, put -1 into your calculator, and hit the square root button. So take -1, put it into your calculator. I implore you guys, if you've never done this before, to do it. Put -1 into your calculator, hit the square root button, and this is what you're going to get. You're going to get error. You're going to get error because the square root of -1 is a completely undefined number. We don't know that such a number exists in reality. And let's just go ahead and think about the kind of the theory behind this, because this is very non-intuitive. This is very non-intuitive indeed. If I take a number like 4, a real number, and I hit the square root button, we know that 2 times 2 equals 4, so the square root of 4 is going to be 2. Simple enough. Easy enough. Well, what do we know about square roots? Square roots of numbers, any kind of number. We'll just stick with 4. We know that it's a positive 2 times a positive 2 equals 4, right? I could also do -2 times -2. What's a negative number times a negative number? Well, that equals a positive number. of course, a negative number times a positive number is going to be a negative number. And I'm not sure if the intuition is obvious here, but how in the heck am I going to get a number times itself to equal a negative number? Because that's what a square root is, right? It's a certain number multiplied by itself that equals the number in question. So how am I going to get, if a square root, I need either positive, both numbers need to be positive, or both numbers need to be negative. I can't have a positive and a negative number, or the square root here, for the notion of a square root. And I think this is where it becomes very obvious that something rather interesting is going on here, that I cannot define I. There is no number that I can define, no number that I can search for that will satisfy the square root of -1. There is no known number. And I would definitely implore you guys to go and try this at home and try to figure out if there is in fact a number, and you'll find out there just simply is not a number. It's a very non-intuitive concept, very interesting. Well, then the question becomes, well, can I do any math, any mathematical, any calculating with this at all? And in fact, we can, and this is where it becomes really crazy, that even though I can't define this number, I can still do calculations on it. I can still do math on it. And there's a whole branch of mathematics that involves complex numbers. But what I want to do is I just want to do some basic calculations on this I, and some really crazy things happen. So let's say that I take I to the 0 power. And I to the 0 power, anything to the 0 power is going to equal 1. How crazy is that? An undefined number can be a real number. So an imaginary number can be a real number if I do some operations on it. So let's just go ahead and take this down some more. Let's say I go I to the 1st power. Well, what's that? Well, that's just I, right? I to the 1st power. Anything for the 1st power equals itself. Let's say I go I squared. So I times I. The square root of -1 times the square root of -1 is going to give me -1. Interesting. Very interesting that an imaginary number times itself, squared, gives me a real number here. Very interesting. Let's go I cubed. Well, that's just -I. And let's go I to the 4th. That actually gives me 1. Interesting. Let's take it one more. I to the 5th equals I. Is there a pattern emerging here? And hopefully it should become obvious. I to the 0 power, 1, is equivalent to I to the 4th. I to the 1st power here is equivalent to what? Well, if I to the 1st is I to the 5th. I to the 2nd, -1. Obviously be further down. I to the 3rd, further down. And what we find is that from 0 to 4, I go from 1 to I to -1 to -I to 1, back to I, -1, -I, 1. And in groups of 4, I come back, or I suppose you could say that I have a recursive number occurring here. Rather interesting. We'll go ahead and cut it off there, guys, and we'll talk about the how complex numbers, or how we can use this concept to actually make a complex number, and what a complex conjugate is. Take care, everyone.